Hello everyone, today I'm going to explain a very innovative and modern concept called the frictionless or Maglev windmill. This is not like a traditional wind turbine that we usually see. Instead, it uses the principle of magnetic levitation, also known as Maglev, to remove friction almost completely. Because of this, the system becomes smoother, more efficient and long lasting. In this presentation, I'll take you through its introduction, working principle, components, fabrications, application, advantages and future scope. Introduction. As we know, electricity demand is growing very fast due to popular growth and industrial needs. Traditional power generation methods like burning coal and oil creating pollution and also depends on limited resources. That is why renewable energy sources like wind, solar and hydro have become very important. Wind energy in particular is freely available, clean and eco-friendly. However, conventional wind turbines still face efficiency problems because friction in the moving parts wastes energy. The Maglev wind turbine, which is a frictionless windmill, solves this issue by using magnetic levitation. This makes the energy generation much smoother and more efficient compared to normal turbines. Need for wind energy. The need for wind energy arises because fossil fuels are limited and harmful due to environment. Every year, electricity demand is increasing, and if we continue to depend on only coal and oil, we will soon face shortages and climate-related issues. Wind energy is renewable, meaning it will never run out as long as the wind blows. It also produces zero greenhouse gases during operation, making it an environmental friendly choice. By improving wind turbines with maglev technology, we can generate more power with less wind and also make them more durable. This is why wind energy, especially maglev based wind turbines, is so important for the future. Concept of maglev wind turbine. The term maglev stands for magnetic levitation. We usually hear about maglev trains that float on magnets instead of touching the tracks, which makes them extremely fast and smooth. In the same way, a maglev wind turbine uses powerful magnets, usually neodymium magnets, to levitate the main shaft or the turbine. Since the shaft is floating on magnetic force instead of rubbing against bearings, the friction becomes almost zero. This means the turbine blades can start rotating with very small amount of wind. Because there is no frictional resistance, the rotation is smoother and produces more electricity compared to a normal turbine of the same size. Advantages of maglev turbines. After explaining the mechanism of power generation in slide 5, I explain the advantages of maglev turbines, which are very significant. Firstly, because friction is removed, the efficiency of system increases a lot, which means more energy output. Secondly, since there is very little wear and tear, the life of the turbine becomes longer. Thirdly, they can work even in low wind speed conditions, which is not possible for normal turbines that need strong winds to start. Finally, because the system is smoother and requires less maintenance, in the long run, it becomes more cost effective even if the initial investment stage is higher. This makes maglev turbine a smart choice for sustainable energy generations. Working principle. The working principles of maglev wind turbine is based on converting wind energy into electrical energy with the help of magnetic levitation. When wind blows, it strikes the blades of the turbine, causing them to rotate. These blades are connected to a shaft, and instead of being supported by normal mechanical bearings, this shaft is lifted using a strong magnet. Because the shaft is levitating, it rotates with almost zero resistance. The rotation is then transferred to a generator motor which produces electricity. In short, the key difference between normal turbine and maglev turbine is the removal of friction using magnetic levitation, which increases overall efficiency. Design objectives. The main objective of designing the maglev wind turbines are very clear. The first objective is to design a vertical axis turbine that can be levitated magnetically. A vertical axis turbine is chosen because it can capture wind from any direction. The second objective is to build a working prototype to test the idea in real life, not just on paper. The third objective is to test and measure its performance so that we can compare it with normal turbines and prove that it is more efficient. These objectives help in showing that the concept is not only theoretical but also practical and useful. Components. The maglev wind turbine is made up of several important components. The neodymium magnets are the heart of the system because they are responsible for levitation. The blades capture the wind energy and transfer it to the shaft. The supporting frame and frame base provide the stability to the entire setup. The generator motor is the part that actually converts the mechanical rotation into electrical power. Bearings and the shafts are also included for smooth operation and balance. Each of these components play a vital role, and the proper combination of all the maglev makes the maglev turbine functional. Prototype fabrication. This explains the mechanism and fabrication. The fabrication of the prototype is done in several steps. First, the supporting frame and base are assembled, which gives structure to the turbine. Second, magnets are fixed carefully in such a way that they create levitation. Third, the blades are attached to the shaft so that they can rotate freely when wind blows. Fourth, the generator motor and bearings are installed to capture the rotation and convert it to electricity. Finally, all these parts are assembled together and tested. The testing stage helps in checking if the turbine starts at low speed and how much power it can generate. Expected performance. This showed the developed prototype and the expected performance. The expected performance of this turbine is quite promising. Because friction is reduced to almost zero, the turbine can start rotating at a much lower wind speed compared to traditional designs. This means energy can be generated even in areas where wind is not very strong. The efficiency of converting wind into electricity will also be higher, which makes it more powerful. The turbine will also have a longer lifespan because the parts do not rub against each other. Overall, the operation will be smoother, stable, and more reliable. Application. The application of maglev wind turbines are wide-ranging. They can be used in rural areas to supply electricity where power grids are not available. They can be also installed in cities as a part of smart grid projects to provide clean energy. On a larger scale, they can be used in wind farms to generate power for industries and residential areas. Because they are efficient and long lasting, they are sustainable for both small scale and large scale power generation. In the future, we might see these turbines being used in many places as a regular source of clean energy. Advantages. To highlight the advantages once again, maglev wind turbines are highly efficient. They reduce friction to almost zero, they can operate across different wind speeds, and they are cost effective in the long term. Even though the initial cost is high, once installed they require less maintenance and produces more electricity over time. This makes them a very attractive option compared to conventional turbines. Limitation and challenges. Like every technology, maglev turbines also have some limitation. The first limitation is the high initial cost because neodymium magnets are expensive. The second limitation is that the magnets need to be aligned very precisely, otherwise the levitation will not work properly. The third limitation is that building a prototype is much more complex and require advanced skill compared to normal turbines. These challenges need to be solved before maglev wind turbines can become common in the market. Conclusion and future scope. In conclusion, maglev vertical axis wind turbines are highly promising technology for generating clean and efficient energy. They solve the problem of friction, which has always been a limitation in conventional turbines. With more research and development, these turbines can become an important part of the renewable energy sector. The future scope includes integrating them into smart grids, using them in large-scale power plants, and improving the material used to make them cheaper. Overall, this technology is a big step towards achieving sustainable energy for the future. Thank you for your time. I hope you have a clear understanding of this now.